So guys, what's a rational number? When we think about the word rational, we should see hidden in it the word ratio. And ratios are comparisons, and usually we make comparisons by making a fraction, like 2:3. So you can think of a rational number almost as a glorified fraction. The technical definition of a rational number is that it's a number that can be written in form P over Q, where P and Q are integers, and here's our caveat, Q cannot equal 0. For example, 2/3 is a rational number because of 2 and 3 are integers and we've written them as a ratio. The whole number 5 is also a rational number because we can think of it as 5/1, as well as an integer like -3 because we can think of it as a ratio of -3:1. The questions, my friends, becomes, why can't we divide by 0? Many times mathematicians say dividing by 0 is like creating a black hole. Why can't we do this? What I'd like you to do is actually turn off this video, take a couple of moments online and Google why we can't divide by 0, maybe watch a video, look at some papers, and write down in your notes on the sheet that I've supplied you why you can't divide by 0. And we'll use these for a springboard for discussion tomorrow. So pause for a couple minutes and then turn me back on. Now that you've looked at why you can't divide by 0, let's talk about what a rational expression is. When we think of a rational expression, we should still think of expressions that can be written in the form of P over Q, where P and Q now are polynomials, a word you've heard before, and Q is not equal 0. For example, 2x plus 3 is a polynomial, 5x is a polynomial, and we have their ratio. You could have something like x squared minus 3x plus 4 over 2 minus x. Again, that's an example of a polynomial. But we still have that caveat that we can't have the bottom ratio equal 0 because we can't divide by 0. So our next task is to say, when are rational expressions undefined? So take, for example, and we'll call this example A in your notes, you had to look at 3x plus 2 over x squared minus 4. This rational expression is undefined when the denominator is equal to 0. So we're going to say to ourselves, what values will make x squared minus 4 equal 0? Most of you can do this in your head. Some will see this as the difference of two perfect squares. And note that x cannot equal plus or minus 2. Following along these lines, in your notes for example B, I would like you to tell me when the rational expression ab squared over 3a minus 2b is undefined. So pause your video and write this down. See you in a moment. Look at how we reduce rational expressions. Let's first just start looking at how you reduce a rational number. Most of you would look at 6/8 and say, hey, we divide the top and bottom by 2 and we're going to get 3/4. Another way to do this, or to think of it, is to think of prime factorizations. 6 has a prime factorization of 2 times 3. And 8 has a prime factorization of 2 times 2 times 2. Now when we reduce, we're really canceling out dividing the top and bottom by the common factors, which in this case is a 2, and we're going to be left with the final answer of 3/4. Well, when we reduce rational expressions, we're going to use the same method. We're going to factor and then reduce common factors. So for example C, which we'll do together, you can think of x squared minus x minus 6 over 5x squared plus 10x. My goal is to reduce this. So we're going to start off by factoring the numerator and denominator. When I factor the top, it's going to become, x minus 3 times x plus 2. When I factor out the bottom, I'm going to factor out of 5x, and then I'm going to have, in parentheses, x plus 2. Notice we have common factors in the numerator and denominator of x plus 2. So our final answer, in reduced form, will be x minus 3 over 5x. But I want you to note that this would be undefined if x does not equal 0 or x does not equal -2, because of our original rational number or rational expression was not defined at those values. So this new term is equivalent to the old everywhere except at x equals 0 and x equals -2. With that said, what I would like you to do is examples D and E in your notes. For D, I would like you to simplify 3 minus x over x squared minus 9. And for E, I would like you to reduce 3x minus 3y over y squared minus 2xy plus x squared. Finish these up and have these completed, and we'll start with these tomorrow. Have a good one.